that we have him here. Thank you very much.
Thank you. Hi, everybody, and good afternoon. This is the perfect talk to give after lunch because it's a. Thank you. This is my son, so it's not. I didn't start that good. This is my son, so he's obliged to do that. So this is a great talk to do after lunch because it's kind of fun. It's light, and it touches many subjects: web application vulnerabilities, some non-obvious ones, cybercrime, Viagra. So I think that we have everything we need to, and we even touched the #1 export industry from Portugal. So it's going to be lots of surprises. And I have 2 T-shirts for the people who will ask questions in the end. I had 5, but some people in here stole some. Okay. So a little bit about myself. This is the one. Okay, so I have 2 children. One of them came with me, and this is his first trip to a cybersecurity conference ever. So this is him. And in my professional experience is from PT, penetration testing, up to head of offensive security in a penetration testing company, and development, several roles up to VP R&D and CTO of a cybersecurity startup. And currently I work for Imperva. Imperva is a security company that has security products, like most security companies. Our range of products is from protecting enterprise databases to protecting web applications, mobile applications, anything that goes over HTTP, HTTPS, and also protecting infrastructures connected to the internet. And I lead the research group for the company. These are also my Twitter and LinkedIn. Okay, so first of all, let's get it over with. I know that this is a talk about Viagra, and we're all expecting to hear jokes about Viagra for the entire talk. So I decided to just wrap it up in 3 slides. So let's get it over with and start. This is the first one. Okay. Okay. This is the second one. And the third one. Okay, that's it. No more jokes. Everybody is leaving the room. Okay, so this is sildenafil citrate, aka Viagra. And this is how our story begins. It started as an experiment of a drug company called Pfizer, which you've all heard about. They tried to find a new medicine for angina, for throat pain and heart issues. And they discovered that people were still having those problems, but were much happier. So they decided that this might sell. And they patented it and started selling it. And of course, the rest is history. Is there anyone in here who haven't heard about this drug? No? Okay, good. I won't ask the second question I usually ask. Okay, so a little bit about the history, the economic history of Viagra. When it came out, as soon as it came out, it took a couple of months, but immediately counterfeit drugs went out because, you know, if it sells so good, then people need to fake it and make it. But then, a couple of years ago, like 6 years ago, some changes occurred in this, which made the industry even more interesting. So first of all, there was a legal battle in Canada about the invalidation of the patent. I think the grounds was the obviousness, but it took about 3 years because, you know, it's a court battle. It doesn't take a day. But the patent in Canada was invalidated. Why it's important to our story? Because in Canada you can buy parallel versions or gray versions of Viagra that are actually made by legitimate companies because it's not patented. And you can buy it for a very cheap price if you compare that with the price, say, in the US. Then in 2013, in some European countries, the patent was expired. So then again, it creates some sort of a vague feeling about this, like parallel import versus counterfeit is very hard to tell, and this gives room for marketing counterfeit drugs. You're saying, this is not counterfeit, this is a Canadian drug that I'm just buying legally in Canada, and I'm sending them to you. So, okay, it's not legal because the FDA does not approve importing drugs, but that's on an economic ground, right? They want to protect the local industry. It's different than if it's made in a workshop somewhere. So then in a couple of years, it's going to be expired worldwide. So then it's going to be it's going to be very cheap worldwide. This is what I was referring to, the #1 export industry of Portugal, right? Cristiano Ronaldo. I guess you all know him. Is the single most valuable athlete in the world. He makes, just from his salary, not including sponsorships, etc., $58 million per year, which is a lot. This is the legal Viagra industry in Cristiano Ronaldo's. So you see how big it is, okay? Okay, so but let's get another image of this. This is the average software engineer salary. Is it true for Portugal as well? No. Wow, that's unanimous. You guys make a lot of money. Okay, so but that's in the US, right? In my country, it's also below average, but it's okay. That's the average software developer salary in Viagra. That was half of it. This is another screen. So we're talking about a lot of money, and whenever we're talking about a lot of money, there's a lot of incentive for people to deal with this kind of industry, either for good, like opening their own online pharmacy that sells legitimate drugs, or to counterfeit, or to start a campaign that will sell illegal versions of the drug. And this is just Viagra. There are many, it's just like in the 30 or 40 place of top-selling pharmaceuticals, right? So there's all types of Revlimid and other stuff. Some of them we've seen in the campaign that are selling 5 times as much as Viagra. But Viagra is catchy, everybody knows it. So, according to the World Health Organization, 10% of the pharma market is counterfeit. That's, again, a lot of money. All of this, again, explains why the attackers have so many resources when they are doing those cyber crimes, because there's tons of money out there. It's billions and billions of dollars in the counterfeit drug market. Something less funny, there's an annual death toll of over 1 million people per year due to illegal pharmaceuticals, due to counterfeit drugs. That is, the source is the Interpol. So I would take that with a grain of salt, of course, because 1 million sounds a bit high. It sounds too high. But there is a death toll of people, and there are stories online of people who just bought antidepressants, for example, online, and just died. So this is also not just economic. This is crime. And this is just the tip of the iceberg. Some of the known campaigns for selling Viagra online, like GloveMed and Spamit, they were exposed a couple of years ago, like 6-7 years ago, and they rolled a lot of money, like dozens of millions of dollars in revenue. So we established until now that this is a market, this is a big market, and that cyber criminals had a lot of incentive to do that. Then it's no wonder why we are seeing so many of these spam about illegal drugs. This is the #1 worst spam in the world. The spam that is the most active in the world. That's called the Canadian pharmacy. And let's see a little bit about how it works. And this is continuous. This is #1 for several years now. So let's say that we want to sell Viagra online, okay? Because we saw that there's a lot of money in it, and we want to make a lot of money. Because in here, we don't make $100,000 as software engineers, we want to make that $100,000. So there are lots of websites that can be searched for in the internet. I'm not talking about darknet and in the internet in Google, especially using Russian keywords because the source of this campaign is in Ukraine. So this is an affiliate program for Viagra, a classical one. It offers 30 to 50% commission. How many of you have done affiliate marketing in here? Okay, you. So it's a lot of fun, but you don't make 30 to 50% commission, right? From Amazon or eBay or anything like that. Unless you're doing affiliate program for Viagra. Okay. So it's a lot of commission. It's definitely, it can be tenfold what you make for some of the legitimate campaigns. You're getting everything you need in order to make this successful. You're getting the banners, you're getting templates for websites, you're getting API support. So if you want to scale your operation, you want to automate things, you have API support. And they know who they're dealing with, of course. First of all, they're saying, where do you take the traffic to once you have established your account, you have your websites, you take your, from email dispatches, which means spam in English. Google Translate did not translate that well to email dispatches. It should be spam, okay? And they put a lot of emphasis. They say, yeah, we know this is the market, and what we also guarantee is a high level of anonymity, because they know that in a lot of cases, in most cases, unlike normal affiliate marketing where you put a lot of content and you expect people to buy legitimate stuff, they expect people to use it in a bad way. So then this is what you're getting. You're getting a template website, okay? You're getting a template website, okay? And you have a lot of templates. Here he has he smiles a lot, he has more hair. But it's the same template, okay? And then you have these sorts of templates. You have Indian pharmacy, Mexican pharmacy, etc. You have special sales. You have everything. They put a lot of faces inside. I saw in one of their in one of the forum posts they have that they're saying why we do this mostly for Canadian pharmacy because it's confusing for people. Canada is seen as a country with high health standards, etc., and the parallel issue of importing drugs. And we're putting a lot of people inside, so it looks really like a normal templated website. So there you have it, all sorts of templates that you're getting. Now let's say that you got all these templates and you want to start making money. So you have several options, not just these two, but these are the main two that you're going to start with probably, right? You either want to send spam, okay? You want to send billions or millions of emails. You know that the click-through ratio is going to be very low. So you want to send a lot of these emails, and you want to bypass spam filters because spam filters are used to this sort of spam. But you want to send it, and then hopefully someone will click that website, and he will be in a moment of doubt, and he will say, "Yeah, I'm taking this." Or you can do SEO. So in one plan, when you're sending spam, for example, you don't want Google to follow this website because you want it to live longer. But if you're doing SEO, you want Google to rank you high up. Now let's say that you want to do the SEO part first. We'll get to the spam as well. Let's say that you want to do the SEO. You need to pick between white hat SEO and black hat SEO. Now to the guy who does affiliate marketing, or did, I don't know, you need SEO, right? Because otherwise you're not making a lot of money. SEO, search engine optimization, you probably all know about it. It's getting your site high on Google or Bing. Since this is Microsoft, let's also mention on Bing. But you want it to be high. So you have two types of SEO services, search engine optimization. You have experts who are doing this legitimately. They're putting a lot of content pages linking to your website. They're doing link exchanges. They're doing a lot of legitimate things within the area of slightly manipulating the PageRank algorithm and the Bing algorithm, whatever it's called. there's also black hat SEO, which means gloves are off. Let's do anything we can in order to get a lot of links to that website. And that is what we are going to do if we're going to send a lot of spam, send people to this website. Because anyway, someone will pull the trigger and cut it off in a week, in a month, in 2 months. But the ISP or someone will send abuse complaint, and your website is anyway going down. So there's no point in investing a lot of money for getting content to your website when it's going to get offline. So this is one campaign that we saw for black hat SEO. And what it does is this. It sends the user agent in the HTTP request. It first sends a user agent, okay? And then it does a semicolon, and it sends this SQL function, okay? This SQL function is basically looking at the metadata of the database at the, not information schema, but for the MS SQL sys databases. It looks for the tables, and it looks for any string columns, like varchar columns. And then it takes it does an iteration on these columns, and then it does some sort of a modulo. It does a randomization, and in 10% of the times, it adds a link to a specific website, and then in some of the other cases, it only adds text. Okay, now the text is aimed at getting Google to understand that this page also deals with this thing. So if you're searching it in Google, you might get it higher up. And the link, of course, gets traffic to your website and also gets a link to your website through Google. Okay? So it was run really high scale, and we have the exact research in our website, in our blogs. And that is what happens after they deploy it. Of course, some of the pages, for example, they just put the text, they do HTML encode, they do HTML escaping. So you just see the plain HTML in the description of the page, and you see so you see the HTML tags. It's not really working in these cases, but it does get to Google with a lot of results, right? So when you're doing it this high scale, and if you're using, for example, one of the WordPress plugin vulnerabilities out there, you're bound to hit something. So that was about SEO. First of all, any questions so far about SEO? Yes? You? No? You just? But now you must. No? Okay. Any other questions? Not you? Okay. SEO is search engine optimization. It means getting your site to be in the top positions in Google. Okay. Okay, so let's go the other way. This is a tough audience, and I have it every day at home, so it's tough every day. Okay, so spam. Let's move to spam. Okay, so there are some simple things about spam, right? For example, domains. Domains is no issue. It's no problem. We register a lot of domains. Of course, once you do it as an operation and in high volumes, it becomes an issue. But then again, it's not that much of an issue to register domains. There are bound to be domain suppliers that don't have enough anti-automation protection, or even you can take people and pay them to register the domain. So domains, let's say that it's a non-issue, right? Registering a lot of domains, or one domain. Email lists are no issue as well. You can scrape for emails, and you can buy email lists in absurd prices. Email servers are more of an issue if you want to send a lot of emails. And remember that the click-through ratio is going to be very low. So you need to send a lot of emails in order to get some money. Okay? So we've seen a lot of web applications attacked by this. This is WSO. WSO is one of the most popular web backdoor web shell. The code is available on GitHub, not GitLab. The code is available on GitHub, and there are a lot of variants for it as well. And then once you install this, once you upload it, say from a vulnerable WordPress plugin to a website, to a web application, you can control that application. And then what we saw was that attackers are doing this. They're sending A in WSO is the action you want to do. So it has PHP, it has, I don't remember the exact names, but you can execute SQL command, you can view files, you can download files. So they're running PHP code, and what they're running is, and that's P. The P parameters are for the payload. So P1, P2, P3 is for payload. Then they're taking a variable, a PHP variable, and they're putting the base64 decode of this string into that variable, okay? And then what it decodes to is a PHP command to run. They do eval afterwards. So they eval this PHP body, a file body. So inside the base64 lies another base64 that gets into a parameter called file body, okay? And what is done with that file body is a backdoor that looks like this, that's inserted into the website. So they're using the generic WSO backdoor in order to add their specific, their custom backdoor. Now let's see what this code does. This code takes an array of the post parameters, and then the strings array is an explode. Explode is split in PHP, like, okay? So it splits it by the pipe character of a base64 decode, 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 that's right, of a base64 decode, of a base64 decode, of the value, okay? So basically it does 8 times the base64 decoding of the string. Now, why would they do it? First of all, they're not very good developers, I guess. I mean, this gave me a migraine when I saw it. And second of all, it says that you have some sort of a system that monitors your traffic, and it sees what looks like a base64 string, and then you try to decode it, and then you're getting another gibberish. And the assumption, I think, if I need to reversing on the psychology of the attackers, is that someone will give up after the second or third decoding, but then this is what it does, and then it gets an array, right? So the array is a structured data set of 2 email, which is the email that we're sending the spam to, subject, body, and header. So then it does again extra 3 base64 decoding, okay, because 8 is not enough, okay, and it gets the strings. Once it gets the strings, it just sends the email using the native PHP mail function, okay. So this is basically they're using the WSO in order to get this specific custom backdoor that gets the payloads, and it's fast. You're sending lots of records from the email list that you have, and with the messages that you want to send, and then you're using it to send spam. But there is a problem in here that we found, and I thought that it was really cool. We'll see if you guys will agree with me. So they're doing all of this base64 again and again and again and again to obfuscate their payload, and in order for people not to be able to see what's in there, right? But that's the first case in recorded history of overdosing on base64, okay? Why is that? This is how base64 works. For ASCII, we have 8 bits, right? 8 bits, because 2 to the power of 8 is 256, right? So we have 0 to 255 in ASCII, right? So this character, this is the non-printable character. In ASCII, it will be 2, 4, 6, 8. It will be until here, okay? This is the ASCII character. This will be its value. In base64, we only take the first 6 bits. There's a certain truncation that happens in base64. Why? Because we're turning the text into 64-bit parts, which is uppercase, lowercase, and two numbers and 2 other signs. All printable characters. That's part of what we want to achieve with base64. The message, because once we do that, we need to concatenate more and more base64 converted strings, will take more space because we're not using a lot of the ASCII characters, but all of it will be printable characters and will be characters that will not do any trouble when we're, for example, transferring them over the web. So everything is great, right? Because we take this and we convert it according to the table, and we're getting this, for example, and then this is M. And then we're adding to it another 6 bits, and then we're getting 6, and then L, and then P. This is how base64 works. But there's a special case with uppercase V. V, you can remember that from Viagra, okay? Base64, 6 bits of V. The base64 is basically a conversion table, right? It's like 1 is A, 2 is B, okay? Like ASCII, but a different conversion table. When we have these bits, 010101, in ASCII, 01010110 is capital V in ASCII. You can check me. You have a laptop open, you can check me. She has a laptop. Okay. With base64, it's the same first 6 bits. So what happens when we try to encode a capital letter V into base64? What will we get? The same, exactly. We're getting a capital V, okay? So every time we will get to a string that starts with a capital V, it will stay a capital V when we base64 encode it, right? But then there are 3 letters who are the first hop from capital V. Okay? Every time you encode T, it will become, in the next hop, a V when we truncate it to a base64. And then this is the next phase. All of these letters, if something starts with a capital L, if we encode it twice in base64, it will become V. Okay? And so on and so forth. So we wrote a small Python script. I hope I have it ready. That it just does this, okay? So even if I don't have it, it's not that complicated. It takes all the characters, and then it does a loop, an iteration, to check how many hops will it take to get to a capital V. And this is how it works. So you see there's this table, and it shows all the hops this character will do until it becomes a capital V. So V is 0 hops, okay? So how is this important? Except that it's very interesting that there's this collision between encodings, which is really cool, and we didn't find any information about it in the internet, so that's also interesting. Either we don't know how to find stuff on the internet, or or it's interesting. So once you have a capital V, okay, this is the base64. This is the base64 encoding. After you have the capital V, you will always have a lowercase m, because that's the next collision. And then you have this string, V, capital V, M, 0, lowercase w, lowercase d, to capital Q and Y. So if you take a string and encode it enough times, like 8 times in that payload, you will get this initial, this prefix. So this was actually, to tell the truth, we first saw the prefix and then we wanted to understand why it has this prefix all the time. But it was very interesting to dig into this and understand the case of the truncating payloads. So, like I said, getting a domain is easy. Email lists are easy. Email servers, we now have them with this by abusing a lot of vulnerable websites and sending them the backdoor, okay? But domain is not enough, okay? We need domains, okay? We need a lot of domains because, like I said, someone will blacklist them, will send an abuse complaint, and then they will shut down, and we will need additional domains, okay? So, when we register the domains, what do we do about it to keep them safe from blacklisting as much as possible? So then another payload that was sent is another base64 string, okay? That was also sent through WSO. And this string was this, okay? It's this string. This is the file body. And then it saves this as .htaccess, okay? .htaccess in Apache servers has configurations for that directory. And then it writes it down, okay? Now, what it writes down is this. It sets the error document to be a redirection to a specific URL. So now, if I take a vulnerable website and I inject this into, all the regular traffic will go fine. Okay, no one will even notice. But if someone makes a mistake and clicks on a link that does not exist, they will get redirected to my website. So now it's less domains that I need to buy, because when I'm linking this, it will link to a legitimate site and not just directly to my site. And the most important thing about this is because there are email filtering, spam filtering services that are looking for links inside emails and are checking reputation databases, those services, either they're doing this active or passive, but when they're looking at the reputation, they're just getting Joe's Garage. His WordPress application was vulnerable, and then this 404 page was inserted into. We also saw some other ways of doing the same thing, basically. We saw an invisible iframe, like inserting gibberish.php, which is an invisible iframe on top of the entire screen, which shows the website, the target website that we want to go through, or JavaScript redirects. Again, the same principle. We're taking a site. Your site is attacked. No one is taking your crown jewels. No one is hacking your database to get, maybe they do that as well. But no one is trying to get your credit cards. But all of a sudden, you find yourself in the 5th page in Google because you have very bad reputation because you're linked to in spam campaigns. Okay. So this is a summary of how this works. So we have the user. Okay, the user gets a spam email. The spam email is sent to a non-existent link on at the attacked website. Okay, then he opens the email, gets the 404. I think I started from the end. He opens the email, he gets to the 404. The 404 is a redirection to the target site that sells him illegal drugs. Okay. The way this gets to is that the domain is injected with the shell in both cases, and then the attacker modifies the htaccess file, and that creates that redirect. For other domains, and sometimes same domains are used for both type of backdoors, a domain is injected with the custom PHP malware. We called it Matryoshka because we have Russian researchers. And it's like that Matryoshka, like a doll within a doll within a doll within a doll within a doll. And so that is the custom backdoor that's inserted in there. And then the spam emails are sent through that site mail function. So once you do that, you need to create a buffer zone between you as the attacker, as the one who's running all of this operation, and your victims. Okay? Now, bear in mind that you're making a lot of money from selling this. So this is a very lucrative type of business. So this was the geographical outspread of the IPs participating just in the operation of routing, then rerouting all of the traffic, because you set the error page to a certain domain, and then there's a system behind it that does all this routing. So tomorrow it will change to another domain because that domain was cancelled, was revoked. So the network that was doing this was huge. It was over 80,000 IP addresses. Okay. Now this operation could have been done with several IP addresses or just by using Tor. But someone really needed a high scalability machine to do all the routing for this campaign and to run all of this. There are several interesting things about the geographical spread, because we saw We didn't see almost anything from the US, and nothing from Canada, by the way, which is surprising for the Canadian pharmacy. But we saw countries that we don't see often in botnets, whether it's DDoS botnets or account takeover botnets, etc., like Egypt, like Algeria. So probably it had something to do with either a browser add-on for these countries or something like that. We didn't investigate that angle, but we saw traffic from unusual locations. And again, when we're talking about scale, because we have a lot of money going on in this system, etc. So all of these domains from this campaign were bought in the same day, okay? And this is constant. This is not like a peak day. This is a random date. There were dates with more domains bought in the same days, but dozens of domains were bought in the same day. Something that was interesting was the different days had different geographical domains. So probably you can see a day that all the domains that they purchased were Indian domains, for example. And of course, these are RU domains, Russian domains. So again, this is operation with a scale that people had a lot of money to invest in. So wrapping it up about this topic, first of all, these campaigns existed years ago, and they continue to exist and evolve because, again, there's a lot of money, and whenever there's a lot of money involved, people will find the motivation to deploy this sort of wide campaigns. And it's always interesting to see the non-trivial attacks done on web applications. For example, the Apache Struts remote code execution attacks that the waves of attacks that we had this year from the different vulnerabilities that there were in Apache Struts. It was brought to the media that, for example, Equifax was hit from Apache Struts vulnerability, and the motivation was very clear: get private information and monetize it, make money from it. And it's always interesting to see other types of activities that cyber criminals are doing. They're infecting your website, but they're not infecting your website just to get your database or get your users or get your private information. They're infecting it to get PageRank, to send mail through it, and they don't want you to find out about what they're doing. So this is something that's interesting about this campaign. So muito obrigado. Thank you very much. And questions? Okay. So question, yes.
You said that there was some. You said that there was some. For the 8 combinations of base64, there was a clear initial string. Are there other initial strings for different amounts of double encoding? So if you have 5 rounds of base64, is there a different initial string that you can identify?
When you do a five-fold base64 encoding, you will get capital V, then lowercase m, because you will always get, if you take something and you base64 encode it 5 times, you will get a capital V eventually from any ASCII character out there. But then, if you take it and encode it enough times, you will always get a lowercase m, because it's the next collision, okay? So you will always get this prefix, you will always get after 8 or 10 base64 encodings of any string. Additional questions?
If the sites are taken down after a month or something, do they really sell anything to the guy that buys the stuff?
First of all, I never operated such a campaign, but I can imagine that they do, because they don't, their philosophy, their psychology is not to get people to trust them over time, like salespeople building rapport, and eventually we will sell something. You're getting into a very directed e-commerce website, okay? And they're saying you have depression. Someone is selling you this drug for $200 for a bottle. You can buy it online because it's parallel import, and you're getting the same thing for $20. So they're building on that, on the fact that this is so lucrative that someone will pay immediately. They're not building on people to make this their homepage and then after a month or two buy it. It's like a landing page. They want people to enter and buy within that same interaction.
Yeah, but do they really send the medicine to the people that buys it, or?
Oh, okay. Now I got this question.
Okay. Credit card numbers, and they don't care about the people.
So there were some researchers who bought drugs from such websites, and they got things. In some of the cases, it was actually the same chemical components, only sent from Mumbai and from China. I don't think that maybe the Interpol or organizations like that did wider tests and investigations, but bought like the entire product line to see what's true and what not. There was an interesting case a few years ago in the US, I think, of a woman that committed suicide after she bought counterfeit drugs, and then in the test they found that it was nothing. It was like nothing related to that drug. So I guess it's like filling the lottery. You may win, you may not, but I would not try this on myself. Any more questions?
Yeah, hi, great talk. Do they get away with using the PHP mail function in 2017, or do they do SPF, like trust things on their domains, or how?
Well, in this campaign they do. It's when you're doing this in such a wide scale. For the other example would be that, for example, adding the SQL injection to the user agent, for example. In 2017, you're right. It shouldn't work, right? And the mail function also shouldn't work. But I guess it does. In low-end hosting websites where the mail function is configured in the php.ini file, and it has the default SMTP server for the hosting company, and then it's used, for the contact form, etc. And then it just works. To what extent, I'm not sure. But
yeah.
But it does send the emails.
Hi, great talk. Regarding this, exactly this attack here, this user agent is used against a specific web server, or?
I think, well, there were some. Both WordPress and Joomla and other applications that had vulnerabilities, plugins, for example, SEO plugins that takes all the user agents and then just doesn't sanitize the data and inserts them into the database. And again, like the same question, it's funny that in 2017 we're still dealing with SQL injection, for example. But we are, and we do see this, and just a couple of weeks ago there were new SQL injection vulnerabilities in core functions in WordPress, depending on the usage that the plugins did. But so it's still a vulnerability that's out there. It's not. If you do this in a wide enough scale, you will get to systems that will be vulnerable.
More questions?
Yep.
Thanks for the talk. I saw that you are also using machine learning, and I was just curious if this is one of the areas where you use it to identify vulnerable pages.
Okay, so we use machine learning in different things. Here, it was not machine learning, but we do use machine learning in some things, and I will just do some bullet points. But if you want, we can discuss this afterward. We do machine learning when we are looking at anomalies, at suspicious traffic. We do two things to it. One of them is to use heuristics, that is domain knowledge. For example, if I'm looking for suspicious payloads, going through our CDN, and we are looking for those specific types of things, and then we see that some of the vectors, for example, impersonated the user agent, like said they're Google Chrome when they're not Google Chrome, or some of them did other various anomalies. We do an automated risk assessment, and that's heuristic part, but we also do a machine learning algorithm that looks for the between 0, which is probably a false positive. If you will try to block it, it will be a false positive, to 1, where this is probably almost certainly an attack, as much as machine learning can be certain of anything. Then we use this as well. So the idea is not to find what we are looking for when we're looking with domain knowledge. For example, okay, if it's a vulnerability scanner, I can be pretty sure that this is an attack. But whereas with machine learning, I can find more interesting things. So this is one part where we're using machine learning for application security. Another part is for clustering attacks, for finding, for example, from 1 million or 100 million alerts or pieces of traffic that were blocked, which ones belongs to the other. Like instead of saying this is 100,000 bad things that happened today, this 12K where someone from your office network ran a vulnerability scanner. Whereas this is a refer spam campaign, so you just need to address bulks. So this is another part, and again, if you want, we can discuss it afterward.
Thanks.
More questions? There's still, I think, a few minutes.
This part, we didn't get any questions from this part, so this is the cool part.
Okay, no more questions? Okay, thank you. Thank you, Brian.
Thank you.